All right. Hello, everyone. Today we're going to be talking about corresponding parts. But before we get into that, if you guys could please pause your video, and I would love it if you would try this problem at the top of the page. All right, answers are up. Let's start with my first one. Now, the first one that I found here actually was angle B. And the reason is because if you look over at our picture, since angle B is next to and forms a straight line with the 107-degree angle, that means these guys are a linear pair. So if I take 180 minus 170 degrees, that leaves me with 73, which is our answer for B. Now, the cool part is that once we now know my answer for B in this case is going to end up being 73 degrees, now we can kind of work our way around, because if I look at this part right here, we have a triangle, and angles in a triangle add up to 180 degrees. So 180 minus 73 minus 45, that's going to give me my answer for angle D, which is 62 degrees. Now, if we know, now the hardest one to probably see on here was how we found angle C. Now, angle C, you're going to notice, is the same measure as angle B. Now, let's think about why that is. If we have parallel lines here, parallel lines mean that we have congruent angles. Alternate interior angles are congruent, alternate exterior angles are congruent, and what we have here is alternate interior. This angle right here is congruent to this angle right here. So that's why angle C also ends up being 73 degrees. All right, so this angle ends up being 73. And if I work my way all the way around, we can see that then the next angle that I said we were going to solve for ends up being angle A. Now, the reason we can solve for angle A is because if I know angle D, and I just realized I didn't write it in, but I know angle D is going to be 62 degrees. Angle A I can solve for, though, because all of these angles are a linear pair. They all form a straight line together. So if I take 180 minus 72 minus 62, we got our final answer for angle A of 45 degrees. Now, once we know angle A, angle F is awesome to find, because angle A and angle F are vertical angles, which means they are congruent. So angle F is 45 degrees. And now angle E is a linear pair with angle F. So 180 minus angle F, which is 45, gives us our final answer for angle E of 135 degrees. So we're still talking about, we could still, like in here, we could talk about corresponding angles. We have all of those angle relationships. But today we're going to really kind of focus on more shapes rather than sides and angles. Now, if you guys please turn to your vocab on page 2. At the bottom of the page, if you need to, please pause your video and you can copy down these definitions right here. But the first one we're going to talk about is side. And these are the 3 lines that make up a triangle. So the 3 straight lines here, if I draw my triangle here, now I am awful at triangles, but if you guys are probably a lot better than me. But a side here is any one of the sides that kind of connects the 2 ends of the line. So that is what we would call a side. Now, corresponding parts, this is really what we're going to focus on for today. Corresponding parts are kind of similar to corresponding angles. Corresponding angles, in a sense, when we did this before, those are talking about angles that were in the same location. Corresponding parts follow pretty similarly. These are parts of a shape that are in the same location. So it could be, for example, we're talking about angles. If I talk about angle, let's call this angle A, and we had another angle over here that was also marked as angle B, and they were congruent, then though we would say angle A is congruent to angle B, and that those are corresponding parts. We can also talk about sides. If I talk about one of the sides of my triangle having a certain measure, and there's another side in this triangle that also has that measure, we would say those 2 sides would also be considered corresponding. Now, how is that going to look in today's lesson? If you guys look down below the vocab section, it says we have corresponding parts of congruent triangles. And what we're looking for in our triangles is we're looking to match up all of the things that end up being congruent. And we can tell this because of the number of tick marks that are there. If I look at angle Q, that's the first one that we're trying to figure out what its corresponding part is. So if I look at my diagram, angle Q is the angle that has one tick mark. So if I go to my other triangle, the other angle that has one tick mark is angle J. So that would be its corresponding part. And it's congruent, whatever the measure of angle Q is. If it's 13 degrees, that means angle J is also going to be 13 degrees. Sides also work the same. If I'm trying to find side PR, I'm going to start by looking for side PR in my diagram. And side PR is notated with one tick mark, which means if I go over to my other triangle, I'm looking for the other one that has one tick mark, which is side LK. So side LK is going to be what we fill in to that. Oops, sorry guys. Now, what I want you guys to do is to pause your video, and I want to see if you guys can fill in these next 4 blanks and go. All right, answers are up. You should have said angle R is congruent to angle K because angle R and angle K have the same number of tick marks. And angle P is going to be congruent to angle L because those guys have the same number of tick marks. Now, if we have corresponding parts of congruent triangles, one of the other things that we can do is write something called a congruency statement. And this is where we kind of match up all of the angles that end up being congruent to the other pieces. So if I look at the angles that are listed, we have Q, R, and then P. So whatever I list in these next 3 spots have to be the angles that are congruent to those angles in that order. So whatever is congruent to angle Q, that's going to go first. So angle Q is congruent to angle J. Whoopsies, wrong one. So J is going to be listed first. R is listed second. So that means K is going to be listed second. And angle P is listed last. So that means angle L is listed last as well. Now what's cool is that this also works for my sides. If I look at PR, PR is congruent to LK. So if I look at where those are in my congruency statement, if I go P to R, L and K are still matched up in the same locations, which is pretty neat. If I do any other sets of sides, if I do P and then Q, well, PQ is LJ, which we already had when we matched up our corresponding sides. So in example 1, that's actually what we're going to kind of look at first here. This says identify the corresponding parts between the 2 triangles. And whenever we say corresponding parts, that means anything goes. That means we could talk about any of the 3 angles or any of the 3 sides. So if I look at my diagram here, we're going to start by matching up kind of the things that we know are congruent. So I'm going to start by looking for the angle that's congruent to angle X. And angle X, since there are 3 tick marks, if I go into my other angle over here, that is angle Z in my other triangle. So angle X is going to be congruent to angle Z. My next one we have here, and I forgot my angle symbol, angle W. So if I find angle W is the one that has 1 tick mark in here. So that in the other triangle, the one that has 1 tick mark is going to be Y in this case. Okay. Now I just realized in the first one, I went on the wrong triangle. It's kind of weird because angle X is in both of them, right? The first shape for us for all of these actually is this first triangle right here. Oopsies. And I'm going to kind of highlight this in a smaller one. So my first triangle here is going to be this guy. So we're always going from the green triangle to the other one. So when I look at angle X in this triangle is this one with 2 tick marks. So that was my bad, guys. I'm sorry. In the other triangle, that is the one that has 2. So we would say angle Z would be the one that would match up with it. And then angle Z is the one that in my green triangle is the one that has 3 tick marks. So the one that has 3 tick marks in my other triangle is going to be angle X. Now, if we're going to do the same things with my sides, what I want you guys to do right now is try pausing your video, and I want you guys to try matching up the sides. and go. All right, answers are up. If we look at our angles here, or excuse me, my sides, we're looking at side XW first. So XW is the side that has one tick mark. So if I look at one tick mark over here, that's side W or YZ or ZY. It doesn't matter which way you write it. My second one is WZ, and WZ has two tick marks. So that would be matched up in the other side. You should have said XY or YX. And then the last one, ZX, this guy ZX in my green triangle is this last side. So that's actually XZ or ZX in the other triangle as well. Now, example 2, all we're going to do, or I forgot, the last thing we got left is to write our congruency statement. Now, this is where we actually go ahead and we match up all of the things that are congruent. Now, when we pick the first triangle letters, it doesn't matter what order we go in, but we want to stay in one triangle. So if I stay within my green triangle, I'm going to start with my green angles. So if we go XWZ, that means when I list out my angle or my letters for my second triangle, we have to go in the same order. So if I went X, then W, then Z, then I have to go Z to Y to X. It has to be listed there. So we'd say Z, Y, X. And then this would be our congruency statement. Now that's actually what we're going to look at to start on example 2. Here it says the triangles below are congruent. And our job is going to be to figure out how to describe these by circling all that apply. So my first one on this one, it says that we're going to check this congruency statement. We're going to actually see if ABC matches up with XY or XZY. So let's see if we look at our triangle, if I'm going to go from, what is it, A to B to C in this triangle, that goes from 1 tick marks to 2 to 3. So let's check my other one. If I go from 1 to 2 to 3, the congruency statement here should have been ZXY, and this doesn't match. That means this cannot be my final answer here. Now, the next one is not talking about a congruency statement, but we are looking at the angle. Angle BAC, that is technically angle A in our purpose. So I'm looking for my second one that it's going to list has to be talking about angle Z. So if we go YZX, I love that because that's my vertex. So B is definitely true. My next one, we're looking at sides. We got side AB and we're saying it's congruent to side XY. Well, if I find side AB, that is my side that has 3 tick marks. Side XY over here has 2 tick marks, which means those are not congruent. That isn't true. Side AB would be congruent to side ZX, the other side that has 3, and this one doesn't. Now, my last one here, we got another congruency statement. We're saying BCA is going to be congruent to XYZ. So let's check. If I go B to C to A, that's 2 tick marks to 3 to 1. So my other triangle, if I go 2 to 3 to 1, it is XYZ and that matches. So that is true. All right. We got one more example. If you flip it over to the back page, there is one change I'm going to have you guys make as of this moment. If you guys could please change this part of the diagram over here. It says 3x minus 5, but I'm going to have you guys change this, cross this out, and please put a 10 in its place. Okay. But let's read this. Let's see what we're doing. It says in the diagram, triangle ABC is congruent to triangle DEF. So I don't have any tick marks on this diagram. So that's one of the first things that I'm going to go and add in. And if I see these pieces out here, since they're outside of my triangle, those are talking about side lengths. So I don't necessarily need to mark my angles, although I could, but I'm going to start with my sides. So I know my congruency statement tells me that side AB is congruent to side DE. And right off the bat, that is something that I can actually use. We found it on the first try, actually. Could we have done this with all the other sides? Yeah. I could have said, for example, side BC is congruent to side EF. BC would be congruent to side EF. but I don't actually know both of those sides. If I already know that two sides are going to end up being congruent, congruent means the same. Whatever has one tick mark has to be the same length. And that's going to help us write our equation. Since those two sides are congruent, that means their lengths are equal. So we can set x plus 6 equal to 10, and subtracting 6 on both sides, we can get our final answer in this problem to be x equals 4. So what I would love for you guys to do next, there are 2 you try now problems at the bottom. I'm going to pause the video right now, and I would love it if you guys would try these problems. All right, answers are up. If you did not get the answers that I got here, make sure you check in with your teacher and see kind of where you went wrong. But at this point, you can now move on and you can start working on the homework for the day.